Hi there, and welcome to this EduConnect video. So today we'll be looking at indices and index laws. Now, the reason we use indices is to make sure that we don't have to keep writing the same number over and over again when we're multiplying. So I'll give you an example. So if we have 2 times 2 times 2 times 2, obviously that's quite repetitive if we have to keep writing out those 2's. So the way we simplify this is we just write 2, and because there's 4 4's here, that's 2 to the power of 4. Alright, now the first law we're going to look at is the multiplication law. So that's when it's a 2 to the power of 4 multiplied by 2 cubed. So when there's a power of 3, so this number over here is called the index or the exponent. And when you say the number, you do the base number, and then you say to the power of the index. So here, in the first one, it would be 2 to the power of 4. And this one here, you could either say it 2 to the power of 3, or because it's a 3, you can say it as cubed. And if it's a 2, you can say it as squared. So 2 to the power of 2 is equal to 2 squared, and 2 to the power of 3 is 2 cubed. Alright, so this is equal to 2 to the power of 4 plus 3, which is 2 to the power of 7. Now why this works is because if we expand this out, we get 2 times 2 times 2 times 2, so that's the 2 to the 4, multiplied by 2 times 2 times 2, which is the 2 cubed. Alright, now that is just 7 2's that we're multiplying together. So that would then be 2 to the power of 7. So this works for anything in indices except when you have two separate. So you can only use this when the base is the same. So say I had 2 cubed times 3 squared. You can't just multiply the 2 and the 3 together and get 6 and go 6 to the power of 3 plus 2, which is 5. That's not how that works. So the only way we can combine bases, essentially, is if the indice is the same. So if you have 2 cubed multiplied by 3 cubed, you can make that into 6 cubed. Now the reason why that works is because you have 2 times 2 times 2 times 3 times 3 times 3. And as you can see, if you pair these up, you can get 2 times 3 times 2 times 3 times 2 times 3, which is 6 times 6 times 6, which is 6 cubed. Now, the next one we're going to look at is the division law, or the subtraction law. So essentially how that works is if you have 2 to the power of 7 divided by 2 to the power of 5, for example, that will be equal to 2 to the power of 7 minus 5, which is 2 squared. Now the reason this works is, say we write it out, so 2 times 2 over so that's essentially what 2 to the power of 7 divided by 2 to the power of 5 is. Now, as you learnt in algebra, you can cancel out common factors on both sides if you're multiplying. So we can cancel out this first 2, second 2, third 2, fourth 2, and fifth 2. Now there's no more 2's left on the bottom, so that the last two 2's on the numerator, they have to stay there. So essentially what you now have is 2 times 2 over 1, which is equal to 2 squared. Now, a very interesting property of indices is the zero index. So when any number to the power of 0. So obviously when you're starting out with indices and exponents, you might think that that's just equal to 0. But the interesting thing is it's not. So if you put any number into a calculator and take it to the power of 0, except for maybe 0 to the power of 0, which might give you a syntax error, you will get 1, which is amazing. Now the reason for this is basically a root, like an exponent is 1 times x, and etc. based on however many x's there are. So if there's 0 x's, it's just 1 times nothing, which is equal to 1. Alright? There's a great video by Eddie Wu explaining this on YouTube. I'll link it in the description. And, well, 0 to the power of 0 is even more interesting. If you put it in a calculator, obviously you get a syntax error, but in that video by Eddie Wu, he also explains how if you keep going smaller and smaller and smaller, so say like 0.01 to the power of 0.01, you get higher, you get closer and closer to 1. So what he says is that's equal to 1. Obviously the calculator has a syntax error, but you know, it's very interesting, and if you enjoy these sorts of things, I'll definitely recommend taking a look at it. So now if we get on to the next component, which are roots. So the root symbol is this. So a square root is denoted by this when it has no number over here next to the little tick. If there is a number, say a 3, that's a cube root. A root to the power of 4, I guess you could call it. There's no really easy way of saying that, and it keeps going. You can go as high as you want. So essentially how this works is it reverses the square. So x squared, x cubed, x to the 4, and x to the 5. So the square root of x squared is x, the cube root of x cubed is x, and etc. So now there are a few rules with this. So obviously root x squared is equal to x, but root x squared minus y squared is not equal to x minus y. Now the reason for this is because x squared minus y squared is not a perfect square. As you learn in algebra pretty soon, you'll get that x squared minus y squared, if you want to make it into a perfect square where it's x minus y all squared, there's another term that you have to put in the middle. Now the next thing, obviously all of these are pretty interesting. The next one is if you have root x times root y, that is equal to root xy, which is pretty interesting. That you'll explore this in further detail when you go into surds and things like that later on. So a surd is essentially if you have, say, root x squared y, that's obviously equal to root x squared times root y because of this rule over here, which means it's equal to x times root y, and you can write that as x root y. So if you have an addition or a subtraction like this, you just can't just take away all the squares. It has to be multiplication to be able to do something like this over here. And a division works as well. So root a over b is equal to root a over root b. Let me clear this up a bit. So roots are very fun. Now, when it comes to actually doing them in exams, you're probably better off using a calculator. But if you want to, and it could save you some time, especially for the square root, you could maybe memorize some squares. So I memorize up to 13, and then for cubes I memorize up to 5. Well, that brings this video to an end, and I'd like to thank you all for watching this video. Please feel free to like and subscribe, and also comment any questions you may have. If you have any further questions or doubts that you'd like clearing up, please feel free to go onto the EduConnect website, which will be linked in the description, and sign up for one of our free plans, where I'll help you by using video calls to clear up any doubts you may have.